Alright, so basically we've learned a bunch of rules about how to integrate some basic functions. And up to this point though, we've been kind of stuck if it's not just one of our rules or one of our basic properties, like, oh, it's multiplied by a constant, so I can just take the integral and multiply it by the constant. Here we have our first in a series of lessons of a little bit more complex functions. Now, the nice thing for you guys is we're not going to get incredibly complex. No, we're not going to AP level here or anything. But we do want to be able to handle certain types of composite functions. And in this case here, we're looking at functions that are composites of a linear function ax plus b. Now that's the key. If you see a composite function, the first thing that you need to look for is to see, is the inner function a linear function? Okay, because if it is, there's a very simple way to handle it. So like in derivatives, we had the chain rule to handle composite functions. You see a function in a function, you do the derivative of the outside, and then you multiply by the derivative of the inside. Here we don't have that, okay? But there is a mechanism or a method that we can use to handle many compound functions, or composite functions. So, notice here we're taking the integral of f of ax plus b, and we're saying that this is 1 over a times the antiderivative in terms of ax plus b plus c. Okay? So, let's look at this first example real quickly over here. I could rewrite this as the function, the integral of 1 minus 2x to the negative 1/2 power. Okay? And you see there a composite function. We have the linear function 1 minus 2x composed inside of the negative 1/2 power. Okay? Well, you guys are aware that if I take the integral of something, and I'm going to use the letter u for it, something to the negative 1/2 power, then I'm just going to use the power rule. I'm going to add 1, so it's u to the positive 1/2 divided by that new exponent 1/2. And then I flip and multiply, and it's just 2u to the 1/2 plus c. Okay? Now, you can see the similarity here. The problem is that we have this inner function, the 1 minus 2x. But what our property here that we're learning today is saying is that you can treat this just like any other thing to the negative 1/2 power. So you can make it 2 times 1 minus 2x to the positive 1/2, as long as you multiply by 1 over a. Now notice a is the slope of that linear function, also the derivative of that linear function. So you're multiplying by 1 over the derivative, which in this case is, we're multiplying by 1 over negative 2. Okay, the derivative of 1 minus 2x is negative 2, so we're going to multiply by negative 2. Okay? So notice here what's going on. We have the capital F of ax plus b okay, and that is this 2 times 1 minus 2x to the 1/2. Okay? We also have the 1 over a that is the 1 over negative 2.
And would you add a c?
And then you would simplify and add the c. So let me get back to pen. Okay, so that's going to be a negative 1 times 1 minus 2x to the 1/2, and then yes, the plus c at the end. Okay. So that's our first example that we can see here of doing the integral of a composite function when the inside is linear. Let's look at one other one that's maybe a little bit more complicated. Okay, we have the integral of 2e to the 2x minus e to the negative 3x dx. And the first thing that I'm going to do here is I'm actually going to rewrite this integral as multiple integrals. So this is going to be 2 times the integral of e to the 2x dx minus the integral of e to the negative 3x dx. Okay? So now I can see, all right, if I think about this, what is the integral of e to some power?
Isn't it just e to that power?
Yeah, it's e to that power. Okay? So that capital F of ax plus b, in this case, we're going to have 2 times capital F of ax plus b is just going to be e to the 2x minus, and then over here minus, here it's going to be e to the negative 3x. Okay? We'll tack that on at the end after we simplify everything. Okay? But we do need the 1 over a part. Okay, so we have the capital F of ax plus b right there. Oop, I've got those backwards. Okay, here's the capital F of ax plus b. Now we need to identify what a is. So what's a on the first integral?
2.
2. So we're going to multiply by 1 over 2. And on the second integral?
It's negative 3, so 1 over negative 3.
Yeah, we're going to multiply by 1 over negative 3. Okay? So there is the 1 over a part on both of those. Okay? All that's left to do is do a little bit of simplifying and add the c. So that's going to be a 1 e to the 2x plus a 1 over 3. And I'm going to go ahead and put that e to the negative 3. I'm going to simplify that and make it e to the 3x in the denominator. And then I have my plus c. Okay? So if you see the pattern, if you happen to see, hey, that's a composite function, but the inside's linear, you can use this method every time. Okay? Yes?
So why is the one on the right, why is that a linear function on the inside?
Because it's just negative 3x. The line y equals negative 3x, you could say.
So it doesn't matter if it's an exponential function, because that's what the x is. It just matters if there's like an a.
Yeah, because notice what has to be linear is what's inside the function. So here, it was a negative 1/2 power, but inside of that was a line, 1 minus 2x. Here we had an exponential, e to a power, but inside the exponential was a line, 2x.
Okay.
And same thing here. Inside the exponential was a line, negative 3x. All right, let's take a look at a couple of other examples, okay? Our next one here involves some trig, okay? So here we're taking the integral of 2 sine of 3x plus cosine of 4x plus pi dx. Now, again, I'm gonna separate this up. As you guys get more and more comfortable, obviously you won't necessarily have to write this all out, but I'm gonna keep doing it for the time being. So we have 2 times the integral of sine of 3x dx plus the integral of cosine of 4x plus pi dx. Okay? Now notice both sine and cosine have linear functions inside of them. So, let's think through this here. What's the integral of sine of u?
Negative cosine.
Yeah, that's a negative cosine. And what's the integral of cosine of u?
Sine.
That's sine. Okay, so my capital F of x, I've got this 2 along for the ride here. Capital F of x when I have a sine is going to be a negative cosine. Notice it's still of 3x. Okay? So that is the capital F of ax plus b part. Then I need to multiply by 1 over a. What's a here?
3.
3. Okay, the derivative of 3x is 3, so I'm multiplying by 1 over 3. So here, that's the 1 over a part. Okay? Now we can tackle the second half. The integral of cosine was sine, so I'm going to put sine of 4x plus pi. I don't need my dx anymore. And then I'm going to, okay, so that is my capital F of ax plus b. And then I'm going to multiply by 1 over a. So that's
1 over 4.
1 over 4, good. Okay, so 1 over 4 is what I'm multiplying by. I do a little bit of simplifying. I've got a negative 2/3 cosine of 3x plus 1/4 sine of 4x plus pi plus c. And that's what my final answer is.
It's not too bad.
No, it's not too bad. Now, tomorrow we're going to learn why this works. Okay? You'll notice the title for this section was Integration by Substitution. You're like, well, where's the substitution? When it's a linear like this, it's a super easy kind of substitution, and we see the pattern is the same every single time. When it's not a linear function inside, it's more complicated. That's what we're going to look at tomorrow. But we're actually going to start with one of these to show the process and also to show why this rule works. Okay? So, one other thing that really comes into play when we're doing integrals with in calculus is those identities that we learned back in pre-calculus. Okay? Now notice here, they have given us an identity that sine squared is 1/2 minus 1/2 cosine of 2x. Right, so where in the world are they getting that from? Okay? Well, let's look at what we're trying to do here. We have 2 minus sine of x that's being squared dx that we're going to take the integral of. Okay? Now, you might say, okay, well, hey, let's multiply by 1 over a, but the problem is inside the squared function is not linear. This is a periodic function, so I can't just do times 1 over something and make it all work out. So our next thought would be what? When we saw something like this and we didn't have a rule for it, what did we try to do to integrate?
Foil.
Yeah, we tried foiling. So let's try that. We do 4 minus 4 sine of x plus sine squared x. Now this is kind of nice because notice these first two parts I can take the integral of now. The problem though is this sine squared. We don't have a formula for sine squared. So we're going to be a little bit stuck unless we can do something else.
Which would be to use the identity.
Yes, the identity that they gave us. Now, I want you guys to see where this identity came from. Alright? This identity actually is derived from two identities that we've used in the past. The first is the basic sine squared plus cosine squared equals 1. And the second is our cosine double angle formula. Okay? Cosine of 2x. It had three different forms. Okay? But the one that we're going to use here is actually cosine squared minus sine squared. Okay? Now you'll notice my identity had sine squared equal to something. Alright, so I'm going to do a little bit of work here. I'm going to replace this cosine, first of all, this cosine right here, squared, with a 1 minus sine squared. And that's how I'm using that first identity. Sine squared plus cosine squared equals 1. So cosine squared is 1 minus sine squared. Okay? So now if I put this together, I've got a 1 minus 2 sine squared is cosine of 2x. So notice now I can subtract the 1. And that's a negative 2 sine squared. And I'll just divide everything by a negative 2. So it's going to be a positive 1/2 minus 1/2 cosine 2x. And that equals sine squared of x. So that's where they're getting this. Okay? You may not always be given the identity to use. But you've had trig, you've worked with identities. So you can handle it. Alright? So now I'm going to rewrite this integral again. I'm going to have the integral of 4 minus 4 sine of x plus a half minus 1/2 cosine of 2x dx. And notice now we can break it up, okay? We can take the integral of 4.5 minus 4 sine x, no problem. Okay? But then we have a minus 1/2 integral of cosine 2x.
And then wouldn't there be an integral? Oh, never mind, you just put it with the...
Yeah, the first two I don't need to do anything fancy with, so we can just go ahead and put those together, alright? So the integral of 4.5 is...
4.5x.
Yeah, 4.5x.
Plus 4, or plus, 4 cosine x.
There you go. The integral of sine is negative cosine, so that's going to give us a double negative. So it's plus 4 cosine x.
And then negative 1/2 times another 1/2, because that's the 1 over a.
Okay.
Times
Sine 2x.
Sine 2x.
You guys agree with this? Or are they pulling your leg? Okay. The capital F of ax plus b, that's the sine of 2x. So we're taking the integral of cosine, that's sine, the inside stays the same. Then we multiply by 1 over the derivative of the inside. That's times the 1 over 2 there. okay? Do a little bit of quick simplifying. We get 4.5x plus 4 cosine x minus 1/4 sine of 2x plus c.